Okay, today the topic is all about the unary and the binary operators. With this, we can conclude the predefined functional interfaces in Java 1.8. This is the last topic with respect to the predefined functional interfaces. Okay, so before coming to the unary operator, right? And what is an unary operator? So the question is why one should go for unary operator, and is there any relationship with any other functional interfaces for this unary operator? So we will discuss about this firstly. So before even discussing about the unary operator, I want you to understand something for the function interface. So when I say function interface, you know what is a function interface. The function is an interface that is going to accept how many arguments? Two arguments. First argument is of T type, and you have the second argument of R type, right? And this T is talking about the input type, and the R is talking about the return type. So you know what is a function, right? So the function is an interface, isn't it? Function is an interface, and this is how you can declare the function interface. So as soon as the function interface is declared, right, it is accepting two arguments. One is the input type and the second one is return type, and there is an abstract method which is what? Public, and the return type of this abstract method is R, and you have an apply method, right? There is a method called apply method. So this apply method is going to accept a parameter of T type. Very straightforward. We have discussed these things already, right? So for example, let us say that I want to do what? I want to do something like I want to accept a number and I want to find the square root of the given number. What I want to do? I want to accept one number and I want to find its corresponding square root, okay, which is going to be what? 100. If I accept the second number like 2, the square root of second number is, the square root of the number is going to be what? 4. Right? If I have this requirement, I can directly go for this function interface. So the simple lambda expression is going to be what? How I can express this by using the lambda expression? How I can write a code to implement this logic, to implement this requirement? Very simple, right? You do what? You do right? You do like function, and you do what? You specify the arguments. It is going to accept the integer, and the return type is going to be the integer itself, right? Okay. So the two arguments that you are going to pass is supposed to be the data type, object type, because function is going to accept the object type. Integer. First integer is the input type and second integer is the return type. You can give any user defined name here, right? And you can give any user defined name. I want to give the name as F, right? So the lambda expression is going to be when you accept the input in the form of I. You can define any variable and you want to do what? I is accepted as an input and you want to return the I square, which is what? I into I. Very simple. Lambda expression is done, right? And you can use the apply method, system.out.println. You can do what? You can call the apply method, right? And you can pass any value inside the apply method, right? When you pass 100, it is going to what? This 100 gets substituted in the this logic, and you will get the output as something like 10,000, right? Square of the given number, right? So this is what function. And if you do some observation here, the input type is integer and the return type is also integer. Both are expressing the same data type. Don't you think so? Input type is integer and the return type is also integer, right? So function is accepting two arguments. One argument is input, the second argument is the return type. And when you make this observation, when both the data types are same, integer, right? When you have this kind of situation, okay, the Java 8 people has introduced an interface, a specialized version of interface called what? The unary operator. Okay? I can just convert this. I can just use this. Convert this function into the unary operator. Not the conversion. Instead of using the function interface, I can use the unary operator. Okay, so this unary operator is designed in such a way that it is going to accept only one argument of what type? T type. Focus here. It is going to accept only one argument of T type. Is what? T type. Okay, so this T is the input as well as this T is the return type itself. Okay, when you are trying to use a function that is going to accept two arguments, one is the input and the second is return type, and when you find that when you make this observation, if the both the input and the return types are of belong to the same data type category, instead of using function, they are saying used to use the specialized version of the function, which is what unary operator. Unary operator is the child interface of function. Okay, this unary operator, you can simplify the logic by using the unary operator like unary operator, which is going to accept only one argument of what type, T type, right? And you have the method like public or public T. Okay, return type is of what type, T. Okay, apply as int. Okay, this is going to accept the T type as the input. Okay, the input is the T type and the return type is also T type. You will pass only one argument, guys. Okay, you are going to pass only one argument. Okay, of T type. This T type is talking about the input as well as this T type is talking about the return type. Because you want to use both the input type and the return type as integers, when you have such requirement, when you find the input type and the return type are one and the same, instead of using the function, you can use the unary operator. Okay, the logic is very simple. I have the set of numbers in the form of array. Okay, by using the function, I want to do what is my requirement actually? Accept the input and find the square, right? So input should be accepted in the form of integer. Input type is integer. The return type is also what, integer. Okay, no doubt still here, right? And f equal to get the input and find the square. Get the input in the form of I, okay, and I multiply by I. You can use this logic. After using this logic, I want to run an answer for loop to convert each and every number, to find the square of each and every number that is there inside this A array, integer array. So that I am taking a integer x or something like b inside the A array, right? While running the for loop, I will use system.out.println. Okay, and I will call the interface function f.apply method, right? This apply method will accept the argument of each and every number that is stored inside this integer array. But when I run this code, okay, you get the output. You get what? You get the square of each and every number. 1496225, that is okay. Instead of using this, what Java people says, yeah, you are passing the same data type as the input, and you are expecting the same data type as the return type, integer. If you have this kind of requirement, do not go for function. You can go for what? Unary operator. Okay? Unary operator define only one argument like integer. Okay, this integer is representing the input type as well as the return type, right? And have the same logic. Okay, let me remove this. And you can have the same, you can keep the same logic. With the idea is this unary operator is going to accept what? This unary operator is going to accept only when you are going to pass the argument in the form of when you are going to pass only one argument. This argument is representing the input type as well as the return type. Okay, the method is let me run this. Okay. Okay, the method is apply method, it's not apply as int. The method is what? Apply method only, not apply as int. I thought it was apply as int. Same as the function method. Okay. Like this, we can write. We can define few other examples. And if my second example is like I want to accept a string. Let us say that I have the array of strings. Let me take some names here. Okay, names are like Ratna and Jyoti, and we have 3 persons today. So list of array of names, array of strings, right? What I want to do, I want to accept the input and I want to get the return type as something like this, unary operator. So my unary operator is going to accept only one argument, right? And this argument is string. Okay, this argument is the input type as well as the return type, right? F is equal to, I will be accepting the input in the form of j. Okay, I want to do what? I want to do a kind of concatenation, j dot concat @gmail.com. I want to collect each and every string. I want to perform the concat operation with this string at the rate gmail.com, so that the output is going to be something like Ratna at the rate gmail.com, Jyoti at the rate gmail.com, Shashwant at the rate gmail.com. I'm generating some emails, some emails. For this, I can go for unary operator instead of going for function, because this argument, this single argument unary operator is going to be the input type as well as the return type. Okay, when I go function, when I try to use the function for to implement the same logic, I need to accept two arguments here, string comma string. Why I need to do this? Instead of doing all these things, I can directly use unary operator when I already know that the input and the return type is same. Right? Instead of using this, I am using this. Okay, so let me run this. Instead of let me go for string in name array, right? So fs dot apply of b. Run this code. Okay. So output is, see how beautiful the output is. Ratna@gmail.com, Jyoti and Shashwant@gmail.com. Right. So this is the importance of the unary operator. It is just same like the function, but the unary operator is going to accept only one input. Okay, only one argument. It is that argument is representing the input type as well as the return type. Right. Now, if you understand one thing, okay, let me go with this example. If you take this example, there is a problem with this example. We'll understand, we will identify the problem. Okay, if you take this example, okay, let me remove this. I think it is not necessary. If you take this example, okay, there is a big problem with this example. What is the problem? We know what is the auto boxing, what is the concept of auto boxing, and we already know what is the concept of auto unboxing. So we have been discussing this for the last 7 days, auto boxing and auto unboxing. Okay, the input, okay, the input type is a integer type, I mean the object type, and the return type is also going to be what? Object type. Okay, whenever you are seeing the unary operator, we'll see only one argument, guys. When you see one argument, so in this case the argument is integer. Okay, always remember that this is not only the input. Okay, this integer is for the input type as well as the return type. Input as well as what? Return type. Right, and you are accepting the input in the form of the primitive type, small int, primitive type. Okay, when you are accepting input in the form of primitive type, this is the input, right? This primitive type needs to get converted to the integer type, I mean wrapper class type. To do this conversion, an auto boxing is required. Okay, it has to go through what? Auto boxing, AV auto boxing. Right? After getting it auto box, okay, after this what is happening? You are performing the mathematical operation. To perform the mathematical operation, again this integer needs to get converted to the primitive type. Right? For this you are, okay, this operation will ensure that, I mean the compiler will ensure that auto unboxing is done, AUB is done, auto unboxing is done, then the values are calculated, and you will get the output as what? 1. 1 into 1 is going to be 1 itself, right? So this one is of what type? Again, this one is of primitive type. This one is of what type? This one is of small int type. Again, this needs to get converted to the capital int so that it will fit the return. It will fit the wrapper class type, which is what? Integer. Okay, there is what? There is an auto boxing, auto unboxing, and again the auto boxing. Internally, compiler is doing all these things for you. Okay, because of this, the performance is going to be reduced. Okay, to address this, to address this drawback, to address the impact of the performance, they have come up with what? They have come up with the primitive versions of unary operator. What is it? Primitive versions. Primitive versions of unary operator. By this you got to know what is auto boxing and what is auto unboxing. We have been discussing this for the last 7 days. Yes or no? Right? So primitive versions. Okay, when you know that the input and the output is an integer itself, okay, when you know that the input and output is integer itself, you can use a primitive version of unary operator, which is what? Int unary operator. This int unary operator is a primitive version. Okay, so this int is representing the input is a primitive version as well as the return type is also the primitive version. Okay, how you can visualize this? Okay, so when you have this interface int unary operator, okay, so this is an interface, right? And it is not going to accept any arguments. Unlike the unary operator, which is accepting one argument, this is not going to accept any argument, because the int itself is representing that, okay, the input is of the return type is of the primitive type, as well as the input is what, of primitive type. That's it. Okay, so this is the declaration of the int unary operator. Okay, you can go with this when you already know that you are going to pass the set of integers, set of primitive integers, and you are expecting the output as the primitive integers. If that is the case, you can go for int unary operator, so that the performance will be what, increased, because it's going to avoid these three steps: auto boxing, auto unboxing, and again auto boxing, right? So obviously the performance is going to be faster. Okay, where is the proof? We cannot see that proof for the smaller data. We are dealing with the big data, right? So then in that cases you are going to see the proof. IF, I mean not IF, let me take it as B, FG, let me take it as C. The same lambda expression I want to take. I want to run a for loop. Okay, this for loop is going to accept the integer, right? Integer x in a array. System.out.println. Call the variable which is g of integer unary operator, g dot apply method. Call the apply method on top of g variable, right? Call the apply method on top of what? On the top of g method. But you need to understand one thing: whenever you are using the primitive versions, right? Whenever you are using the primitive versions, please ensure that the method name is going to be changed as apply as int. Okay, this is one thing that you need to remember, because it's a primitive version of unary operator, right? Whenever you are dealing with the primitive version of unary operator, the apply method will be changed to what? Nothing, just concat into as int. This as int is representing that the return input type is being accepted as int, right? Apply as int. Run this code, you can see the output, but internally it is avoiding what? Auto boxing, auto unboxing, and again the auto boxing. Okay. Like this, you have the primitive version for int unary operator, int operator. You have also some of the primitive versions for the unary operator, which are, let me copy this, int unary operator. Okay, there are about 3 primitive versions: long unary operator and the double unary operator. Long unary operator, this is going to deal with the long data type, long primitive data type, and you have the double unary operator, which is going to deal with the double primitive data type. So these are all about the primitive versions of unary operator. Okay, let us understand about the binary operator. Okay, when you already know the predicate, function, supplier and consumer, these things are very, very easy. Just need to understand the method names by just looking, interface names. By just looking at the interface names, we will get the complete picture. Okay, now let us understand what is binary operator. Unary we got to know. We will understand what is binary operator. Before understanding binary operator, I want you to understand something here, guys. Okay, let me keep this for you. Let me remove this. Okay, do you remember that we have something like by function? Function is going to accept only one argument. By function is going to accept 3 arguments. My function is going to accept 2 arguments. By function is going to accept 3 arguments. The first 2 arguments are representing the 2 inputs. The last arguments are representing the return type, right? For example, let us say that this is accepting first argument as the string, okay, and the second argument as the string, okay, and it is going to return the type as string itself. The 3 arguments are string. The first 2 arguments are 2 inputs. The last argument is a return type, right? Let me take it as B. Okay, I will be accepting 2 strings here. Let us say that A comma B. After accepting 2 strings, I want to do what? I want to perform a kind of concatenation. Okay, I want to concat A with B. A simple logic. Okay, after doing all this, if I call the for loop, enhancer for loop, my enhancer for loop as what? Okay, of string type x in name. Okay, system.out.println bf dot apply. When I call apply method, this apply method will accept 2 strings. First string is Ratna will be accepted, second followed by Jyoti, third is okay. It is accepting 2 inputs. First input, let it be, let us say that the first input is getting extracted from the string array one by one. And the second input is @gmail.com. Okay, two inputs are the string. First input and the second input, right? When the unanswered for loop is on the run, okay, this is the string, right? I should be using this in the double quotes. Okay. So when the unanswered for loop is on the run, okay, this apply method is going to accept two inputs. First input is string, second input is string. So the first input is collected from this name array, right? And the second input is hard coded like @gmail.com. Always it is @gmail.com. If you run this piece of code, you get something. Ratna@gmail.com, Jyoti@gmail.com, Shashwant@gmail.com. Okay, if you don't like gmail.com, then use yahoo.com. Okay, and you get the respective corresponding answers. Right? And if you don't like yahoo.com, you can give any other apc.com. You can outcode it in the runtime. Just an idea. Okay, by function is accepting something like this. Okay, and you need to make one observation here. What is that observation? In order to make this observation, I want to use this paint screen. So my paint screen as the by function. Right? And if you make some observation, all the data types, all the input type as well as the return type is of the same type, right? Two inputs are of string data type and the return type is also of string data type. When you have such requirement, why you are going for by function? You can go for what? Unary operator. Sorry, binary operator. Binary operator. Binary operator is a child interface of by function. Okay. So the binary operator is going to accept only one type. Only one type. Okay. So when I say T, okay, when I say T, this T you take the T as string. Okay, this T, the input type is, if you have all the three types as one data type, okay, this T is representing this string. When you just do the equivalent conversion, okay, this T is representing string, string and string, these three strings. And when you look at this by function, okay, by function is typically accepting two inputs and one return type. All of them are the same data type. To find every data type is same, instead of using by function, go for binary operator. Okay, and you will declare only one argument here. Here you are declaring three arguments. Don't declare three arguments, declare only one argument. This one argument is going to be the string type itself. Okay, how you can write a program for the binary operator? Okay, let me write a program for the binary operator. Binary operator. My binary operator is accepting on type. I want to convert this. I want to do an equivalent conversion of by function to the binary operator. Okay, I will take the string. Okay, this one string is the first input as well as the second input as well as the return type. You will declare only one argument here. Apart from that, nothing else here. Okay, BOF. I am taking it as BOF. Okay, the logic is going to be same. The logic is going to be what? Same. Right? And if I run this, if I put the for loop here, okay, let me check this. BOF. Okay, BOF. I'm using what? I'm using the binary operator. I'm using the apply method. Okay, I'm using the reference variable of binary operator. If I run this piece of code, output is going to be same itself. What is an advantage here? You don't see any advantage, but typically when you look at the code, right, in the arguments, okay, so when you accept the arguments, it accepts three arguments. Why you should declare three arguments? No, so instead of using this, you can go for binary operator, which is going to do the same work like the by function, right? So like this, there are some primitive versions for binary operator also. We have completed discussion about unary operator. We will discuss something about primitive versions of binary operator. Primitive versions of binary operator. Okay. So let us say that I am going to accept. Okay, I want to write a program. I want to write a program to accept two integers and find their product. Okay, So how I can write this by using the function. If I use the function, right, what is my requirement? Two integers I want to accept. Okay, I want to accept, let us say if I am accepting 10, and if I am accepting 10, I want to find the product. Okay, 10 into 10 is going to be what? 100, right? And if you see here, first input is integer, second input is integer, and the return type is also integer. I'm dealing with three integers, isn't it? Integer, 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 right? So when I use by function, okay, to achieve this conversions, okay, when I try to use the by function, let me remove all this. When I use by function, my by function has to have the three arguments, isn't it? First one is of what type? Integer type, first input, and the second one is representing the second input. The third one is representing the return type. Integer, 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 right? So BF, reference variable name. Okay, I will accept two inputs a comma b. What I want to get the product of two input a into b. A simple lambda expression. When I call this logic by using bf dot apply method, if I pass two inputs, something like 100 comma 30, let us say that a person is getting 1000 rupees per day and is working for 30 days, right? And his salary is going to be how much? Get 30,000, right? And we have already discussed, when you have three inputs like this, okay, we can go for what? We can go for the improvised version, which is called as what? Binary operator. Okay, this is going to accept only one argument, integer. This one argument is going to be the first input as well as the second input as well as the return type, right? So PO binary operator if I'm taking, okay, same logic I am applying here. Same logic applying here. Let me print this. Okay, and POF dot apply. You will accept two input. Let us say that the salary of the person is 2000 per day and is working for 24 days in a month. Okay, it is going to give me the same product of the what 8000. Accept two inputs and it is going to give me the product. Okay, this is how you can write the binary operator. Okay, but here the problem is, even though when you are doing some improvisation or doing some optimization from binary function to binary operator, there is a problem here. Okay, this integer needs to get converted to the primitive type auto boxing, right? And to perform this operation, again it has to go through the auto unboxing. Compiler will do that, and again after getting the output, again it needs to be auto boxed. Okay, three times auto boxing, auto unboxing, and auto boxing is happening. Okay, to avoid this kind of situation, they have introduced the primitive versions of what? Binary interface. Okay, the same program I can write by using the primitive versions. One is what? Int binary interface, int binary operator. Okay, so it is going to be what? Int type only, primitive type only. Input is int, first input is int, second input is int, and the return type is also int. Okay, IOP. Okay, I'm accepting same logic I'm going to use a into b, right? System dot out dot println IOP dot apply as, the method is apply as int. For primitive versions, use this apply as int. If it is long, apply as long. If it is double, apply as double. Will accept two arguments. Let us say that the salary of a person is 3000 per day and is working completely for 25 days in a month. It is going to give me an output. You will get an output in a beautiful way. Why? Because internally the conversions are avoided. Auto boxing, auto unboxing, and auto boxing is avoided in this case. Primitive version. This is what primitive version. Okay, you might be thinking everything is giving me the same result, but when you understand the concept of auto boxing, auto unboxing, then you will realize that performance wise this is perfect. Performance wise this is not at all recommended, right? When you have such cases, okay, there will be a situation where you are exactly supposed to use the by function. When you will get the situation, actually, when you are dealing with different data types, first input can be integer, second input can be string, third input can be the employee object. Okay, there will be such situations. In those cases, you need to look for you need to use this by function for sure, because you cannot do any more conversions. I mean, completely you should be dependent upon this by function, right? So when you get an option that where you will find a way to do some improvisation, then you can go for primitive versions. So this is the best example. when you find all the inputs are same, two inputs are same and the return type is also same, right? So like in binary operator, you have the two other binary operators, like the first one is int binary, second one is what, long binary operator, okay, and the last one is what, the double binary operator. Okay, so what we have discussed today, we have discussed only the unary operators and the binary operators, their primitive versions of unary operators and the primitive versions of binary operators. So these are the primitive versions for unary operator and these are the primitive versions of binary operators. With this, predefined functional interfaces are completed. Okay. So Java 8 is not completed, so we need to, tomorrow we will be discussing about method and the constructor references. Okay. After completing this is going to be only within one class. Tomorrow it will be completed. Then we will start discussing about what stream APIs, right? So this is a little bit difficult to understand, but don't worry, I will make it very simple. You don't expect this kind of explanation. You could not find this kind of explanation anywhere in the in the YouTube or any kind of lecture somewhere. Okay, that's all from my side for the day.